a half, and then the power is t be x over whatever that half-life is, and it'll tell you the half-life is something. Okay. Now double time is when it's doubling, not dividing in half. So double time, y equals a times, oops, I almost wrote a half, times 2 times t over d. And we're using d for the double time. So t is the variable that stays. You will fill in something for d. So Mr. Bean's parents currently have 95 descendants. The number of their descendants doubles every 15 years. So y equals, so the initial amount is 95. Since it doubles, my ratio is 2. It's multiplying by 2, but it's every 15 years. So we do t divided by 15. So for example, if it's, so t is your number of years. If it's been 30 years, it's only going to have doubled twice at the 15 mark, and it's going to have doubled at the 30 mark. So if it's been 30 years, 30 divided by 15 is 2. That's why that fraction is there. So you think, how many times has it actually doubled? Same here for the half-life. If it's dividing in half every 4,400 years, if it's been 500 years, it's really not even halved yet. So that would be less than 1. Certain fish species was introduced into a tidal basin 10 months ago and is doubling every 5 months. The initial size of the fish population. So that initial size is A. We don't know. We know that it was put in 10 months ago. But now it's 220. It wasn't 220 to start with. Okay. It's doubling, so it should have been less than that, right? So the function that we're going to go with would be y equals a times 2 to the t over 5. So some initial value times 2 because it's doubling, and then it's t over 5 because it doubles every 5 months. So this one, everything in this problem is giving us information in months. You will need to be careful about your units. If it gave part of it in months and part of it in years, we'd have to figure out how to change that. So I know that it's currently 220. And it's been 10 months. So when t is 10, my y is 220. So if it was put in 10 months ago, it's 10 months have elapsed. So my t is 10. And then it's 220 now. So a times 2 to the 10 to the 5th, 10 over 5. So that's squared. So this is 4a, because 2 squared is 4. So if you divide that by 4, you get 55. You feel like what? Normal? Yeah. And actually, like, I was looking ahead after we take this test, like, we're doing like the next lesson is composition of functions, which we did in Algebra 2, and I think it's going to be, it seems, at least the first lesson that I've looked at seems easy. So, okay. All right, number 10, estimate the population of the fish 1 year after they are introduced into the tidal basin. So because we found this A, I know that my function is y equals 55 times 2 to the t over 5. And remember, t is a number of months, and it wants to know 1 year after. So what am I going to put in for t? 12, right? So y equals 55 times 2 to the 12 over 5. And we get 290.29174 fish. Suppose a half-life of a radioactive substance is 40 days and there are 8 grams present initially. So that one's just giving us our initial value. We don't actually have to figure anything out. Write an exponential model to represent this. So it's y equals, it's always, you start with your initial amount, which is 8. My ratio is 1/2 because it's cutting in half. But it's not just to the x power, because that would be 1/2 every year or every month or whatever our unit is. It's t divided by 40, because it's the half-life is 40 days. So every 40 days, split in half. Every 40 days, it's half of what it was before. Find the time when there will be 1 gram of the substance remaining. So t is not 1. Where does the 1 go?
Y.
For y. So it's 1 equals 8 times 1/2 t over 40. You don't know how to algebraically get this. Do you remember what I showed you to do in the calculator yesterday? This is where we went to the y equals. And in one of them, I put just the 1. And in the other one, I put my equation. And I'm going to find where those two lines intersect on my graph. So if you have an equation equals a number, you could do this all the time. Like, this would work. Solving equations, 2x plus 5 equals 30. You could do this to figure that out. Now, that's a ridiculous amount of work for something that simple. But a question that's harder like this, you have an equation equal to a number. We can look at both of those, graph them, and then see where they intersect. So zoom 6 is your standard negative 10 to 10. And it does not look like it's going to fit on there. So you have a few options in your calculator. So zoom 6 was zoom standard. Standard is the negative 10 to 10. Zoom fit, ideally it would kind of give us, it would change the window to fit our functions, but it's not always perfect. See, it does not do what I want it to do. So we could do zoom out. We can zoom out to see. You got to hit enter to zoom out. Still didn't get it, but I'm close. So I could zoom out again. So I went to zoom out and you have to hit enter. Okay, so this might be enough to find out where they cross. You could also just go hit the window button and change the numbers on the window to try to make it work. You got to just get the graph to show your two lines. to show them crossing. So second trace where it says calc, number 5 is intersect. First curve, my numbers are in blue, that's on the blue one, hit enter. The second one, it jumps up to the red, and then guess, go close. And the intersection is when x is 120. So those two things crossed at 120.